All right, the last online lecture of the unit, potentially of the year. I haven't decided if I'm going to uh, do any more. So, limiting reactant. Remember, this is the. I mean, it makes sense. It is what it's the reactant that runs out first. All right. So, in the real world, substances are rarely mixed in the exact mole ratios of a chemical equation. So, in order to figure out the limiting reactant, the number of moles of reactant must be compared with the moles of product. This is so you need to use product produced. That's a weird way of saying it. So you use the mole ratio. So I'm going to add a slide here. We're going to do a practice problem so you guys can see it. All right. So say we have a chemical reaction that is, all right, we'll do this one. We'll have zinc solid plus copper sulfate solution makes solid copper plus, you know what, I don't want to do that one. Sorry, guys. Let's erase that. All right. We're going to do this one. Going to make it a little trickier for you guys. You guys can do it, though. Solid sodium reacts with copper sulfate to make solid copper and, well, so we need to know what the charge is of these things. So we know SO4 is -2. Na is going to be +1. So I know I need 2 NAs to balance off the sulfate. And now if I balance the chemical equation, 1A on the left side, 2 on the right. Well, I know I need another Na down here. 1 copper, 1 copper, 1 sulfate, 1 sulfate. So really, it's just 2, 1, 1, 1, 1. All right, so let's say I have given 10 grams of Na and 500 ml of 0.1 molar CuSO4. How many grams of copper can be made? So what I need to do, that's a period. I don't know why it's so high up. So what I need to do is first figure out the moles of each. And I'll do this in a different color. So A, moles of each. So for Na, I have 10 grams. I look at the molar mass of Na. I see it's 22.989. I'm going to call it 23. It's 23 grams per mole. So I have 10 grams of Na. Well, if a mole is 23 grams, I know I have to have less than 1, so we can logic it out that way. Or I can say 10 grams, 100 grams on the bottom, 23 grams per mole, and I get 10 divided by 23, which means I have to take out my calculator. 10 divided by 23 equals 0.43 0.435 moles of Na. So for copper sulfate, well, I know I have 500 milliliters, and in each liter I have 0.1 moles. So first I convert milliliters to liters, so I know that's going to be 0.5 liters. In every 1 liter, I have 0.1 moles. So I know I have 0.05 moles of copper sulfate. Now in this case, it's pretty easy because we can figure out, we can just look at it and say, oh, well, odds are that my copper sulfate is going to run out first. But let's just make sure. So we use the mole ratios. So for Na, I have 0.435 moles of Na. Well, from my balanced chemical equation, I know I need 2 moles of Na for every 1 mole of copper. So I get 0.218 moles of Cu. For the copper sulfate, I have 0.05 moles of CuSO4. I know my mole ratio here, it's 1 copper sulfate for every copper. So 1 mole copper sulfate for 1 mole of copper, and I get 0.05 moles of copper. So now I take, which one's going to run out first? Well, the one that makes less runs out first. So I know that copper sulfate is my limiting reactant. No, I just used that color. So limiting. Now, so I can ignore the sodium because I know that I'm still going to have some of that left. Well, so now you use the copper sulfate. I know I have 0.05. I know I can make that many moles of copper. So I want to figure out how many grams that is. So I look at the molar mass of copper. I know 1 mole of copper is 63.5 grams. So I have much less than a mole, so I know it has to be less than that. But 63.5 grams per 1 mole. And again, I need to do this out. It's going to be something around 3, but 3.18 grams. So that's solving one out the entire way. We're going to practice with this in class. This is like, if you sort of understood how I walked through this, you're in great shape. All right. Which reactant determines how much product is made? The limiting reactant is the substance that gets used up in a chemical reaction. To determine the limiting reactant, calculate how many moles of each reactant you have, then use the mole ratio to see which gets used up.